Good afternoon, everybody. My name is Wayne Workman. I work for Sealed Air, principal engineer. For those who may not be familiar with Sealed Air, we're a protective package company. I'm sure everybody's heard of bubble wrap. We also do films and trays and laminates and plastic bags. Anything you can wrap something in, we'll put it in. But we also have a major division for equipment. So that's the side that I come in. So along with the materials, we like to sell the equipment to package the materials and package your product. So a few years back, we went down our path of our digital transformation, and we started a new division, our SEE Smart Service Link. Whoops. So as we went through for our Smart Service Link, we had our basic project overview and our challenges. We were challenged to design a system capable of collecting data remotely from all the different equipment platforms manufactured or distributed by Sealed Air. So these are ones that we may not make, but we're partnerships with a lot of other companies. Our needs, we must be able to connect to multiple brand PLC controllers simultaneously when to send data to AWS using MQTT. We wanted to follow a standard data structure using OMAC PAC-ML for naming conventions. And we wanted to have the same format regardless of what piece of equipment we're talking to, regardless of the manufacturer, controller, or what, everything we wanted to be the same. And our final outcome, we wanted the data to be ingested to AWS. We're going to analyze it with our data science team and then take the findings, feed it back to our customers to help the overall performance. If the machines are running better, they're running more product, they're running more product, they're running more material. More material for us means more profits. So the quick topology, we would have our piece of equipment, our packaging piece of equipment. The piece of equipment would capture the data. It would generate the data, looking at machine data, process data, looking at machine states, machine modes, machines alarms, just anything you could think of that you want to capture and monitor. This data will be sent up to the cloud. We actually have a group, our solution center, that can monitor all of our connections remotely, and they'll analyze the data. They'll actually be proactive and contact the customer when we think there might be a problem. And that allows the customer to, again, keep the machine running more efficient, and again, keeps us cranking out more material. And then we also give the customer feedback through a dashboard, just custom tailored to their unique piece of equipment. So they're able to monitor their OEE through the dashboard. We also monitor with a dedicated group of people because we are the equipment experts, so we can identify problems sometimes before the customer even knows something's happening. Whoops. So as we go through, as the first challenge was multiple pieces of equipment across our whole range of platforms. So our platforms vary greatly. They're manufactured all over the world. We have equipment manufactured in right locally in South Carolina, where we're based at. We have equipment manufactured in Switzerland. We have equipment manufactured in Japan, New Zealand. So it comes from all over the world, various platforms. Back 1 second here. So we'll have various, like rotary machines, we'll get into robotics, carton machines, vertical form fill machines, various types of auto loaders, various types of shrink tunnels, automated conveyor systems. It's really a very wide range of products and platforms that we have. So the challenge is, how do we connect to everything? And that was my responsibility. I was given a task 4 years ago that says, your job is to connect to every piece of equipment we have. I said, every piece of equipment? They said, yes. I said, how far back? As far back as you can go. So this covers legacy equipment, existing equipment, and new equipment. And some of the legacy equipment, it's been out there running 20, 25 years. So I'm going, no problem, we can do that. So as I look into it, we got multiple machines, platforms, but also multiple control systems. So we have some older Omron systems, a little bit newer Omron, still yet fairly new Omron, Mitsubishi's, Allen Bradley, Siemens, very Siemens, Schneider. We even talked to some Videojet printers. We'll talk to various SCADA systems, had to talk to industrial computers. So we have all these control systems that we wanted to extract data from. We wanted to extract the data in the same format. We wanted to push the data up to the cloud in the same format. And then we wanted to present that data back to the customers. Okay? So that was our key challenge, is how do we manage the connection of everything, format it in a standard format, get the data, and present it back to the customer. So as we go through this and we start our process, we start coming up with our system requirements. So as we go through, first and foremost, hey, we need a system that we're able to collect data from multiple brand PLCs simultaneously. Now, everything is remote also. We are connected to our customers' plants collecting data. So every piece of data we collect is being collected remotely. We want something that would definitely have independent Ethernet ports so we can isolate networks. We wanted, if all possible, to find a standard industrial off-the-shelf solution. We don't want to have to go kind of roll our own and try to reinvent the wheel. So we want to definitely try to find something that was readily available, that we knew we could have some good success with. Of course, the DIN rail mount, 24-volt connection, just standard industrial platform is what we wanted. From a software standpoint, we wanted something with built-in drivers. We don't want to have to pay a license for every single driver, for every single control system that we wanted to talk to. So we wanted something that would provide us that capability of talking to multiple pieces of equipment with multiple drivers already included. We wanted to, of course, be able to send data to AWS over MQTT. We wanted standard naming conventions for all of our tags based on PAC-ML. And what that provides us is, as the data from all these different platforms and all these different controllers are pushed into the cloud, now we're able to create dashboards with standard templates, with standard naming conventions, regardless of the machine itself. Okay? We wanted to use OPC-UA as another option for communication protocols. And we wanted a non-Windows operating environment. And this was not an easy requirement to come up with, because it took a lot of years of trial and error of what not to use and what not to do to get to this point. So what you see here is a lot of what didn't work and finally what we needed to make it work. So as we scoured out across industry and we started evaluating all the different systems and all the different tools and all the different controllers, we came across the Redline FlexEdge DA50. It's their advanced protocol converter. So as we started looking at this particular device, for one, we needed a gateway. It provides a gateway, but it's just more than a gateway. It provided all the other features we were looking for. So this single device for us is supported up to 10 different protocol drivers simultaneously. So as we had that list of all the different controllers, the Omron, Mitsubishi, Siemens, it had those built-in drivers. I had to pay for any additional license. Right off the shelf, away we go. We can put multiple connections per protocol. So we may have an instance where we had a plant may have 5 of our pieces of equipment. They're all the same piece of equipment. They're all the same protocol. I could put all 5 into one protocol. Has over 300 built-in protocols. So I haven't found anything yet that I haven't been able to talk to. No license required. It is a Linux system, which was a big plus in our books. It does support MQTT, AWS IoT, or OPC-UA, built-in NAT functionality. Also has built-in security. That's always a very, very critical one that we need to maintain is secure networks as we deploy these out to our customers. The software to program it was free, so no additional charges there for us being OEM. built-in web server for HMI. We were able to generate our own web pages with built-in graphics. And of course, it was industrial grade construction, again, rail mountable to fit into our standard enclosures. So the basic architecture that we're using, we have an enclosure, our system, our link system, that we deploy out to our customers. At the customer site, this system that we have, it's able to connect up to 10 pieces of equipment simultaneously. This is an example here of multiple controllers, which simulate 6 different pieces of equipment, all being our equipment, all on maybe same process line, maybe different process lines scattered throughout the plant. So what this has been able to do for us is being able to remotely connect to the equipment, be able to extract the data. Since we are the equipment expert, we know exactly the proper data to pull out of it. We know how to analyze it. So this data is being sent up to AWS, and then we actually have multiple groups. We actually have a digital group which does all the dashboards based on all of our standard data templates and day-to-day KPIs, but we also have another group that does just data science. So we're also taking this large amounts of data from multiple customers throughout 3 different countries, and now we're able to analyze if we have a machine, a customer here, and the same customer at a different location has that same machine, we're able to correlate and see how well they're running. And that same customer can have access to both of their pieces of equipment also. So that really, what we're trying to do is for one to be proactive. We're trying to find with the data science any sort of anomaly that would typically be missed in the day-to-day running of production that the maintenance might miss or that you know the people on the floor would miss. And we're able to find subtle changes in machine performance that we can be proactive and say, look, you've been running steady now, and you've been running at a certain speed, you've been running at certain voltages and currents, and you're pulling certain vacuum. But over the last week, we've seen an increase in your vacuum. You haven't met the threshold yet that you're going to make a bad package, but you're getting close to it. And at that point, we can contact the customer or have our tech service go in, and they can look at the vacuum pumps. They can look at any system on the machine, and they can run tests, and they can determine that, okay, we have a problem before we actually have a problem. So that right there, and I know we talked about, and other speakers have too, the downtime factor, the cost of the piece of equipment going down is huge. And most of these equipment, they're part of a process line for food packaging. So it may be a beef plant, maybe a pork plant, it may be a poultry plant. Okay, so and we have a lot of vertical machines, you know, the package any form of liquid, maybe tomato paste, you know, just any sort of food product we package. So any amount of downtime is huge. So at the end of the day, this has really been providing us also with a new revenue stream. Okay, so we're providing the information back to the customer. We're able to help them. We're able to keep the machines up and running more efficient. We're able to actually keep them in our materials. If they're running better, we're selling more materials. But also, it's able to provide us a completely new revenue stream that allows us to sell the data back. Because a lot of customers that we deal with, they don't have the infrastructure, they don't have the skill sets or the technology in-house to actually connect, extract the data, and do what they want. So we're able to provide that to them with a single installation of a single enclosure for multiple pieces of equipment, and now they have access to all the data, access to our data science, and they don't have to do anything other than sign up for our subscription. Okay, so far we've been deployed in 3 countries. We have over 150 machines connected, and And when they're connected, it's connected permanently. We're sending data continuously. Every machine cycle, data's pumping through. We're getting machine statuses, like I said, alarms, machine modes. We know key parameters for every machine cycle that we're able to capture on a machine cycle trigger. So we'll know if this particular package was made, it was made with this vacuum level, it was made with this seal current, with this seal voltage. We can package that up. This year already, we have 75 new machine connections lined up. So things are accelerating really quick for us. We've already collected millions of data points that's currently being analyzed by our data science group. And they continuously come back to us and we'll find something and we can dig deeper into it and make the decision if we have to maybe make a modification to the machine or if that's just a normal anomaly. And the data that we've provided back to the customers, they use that to improve their overall process. So they're getting increased throughput, they're getting decreased downtime out of it. It also helps provide, when we have the data, of making data-driven decisions for automation, not just making what we educated decisions. So now we're able to look at the data from machines, millions of data points running, and look at the process and make the decision of, okay, our next generation machine should have this new functionality because we have a lot of these particular issues right here. And we also have been, this has also been a key factor in our development for new equipment. As we develop new equipment, we will deploy our system for us internally, and we can actually monitor all the status of new equipment to help us further develop that. And then as a feedback to the customer, we're able to generate the dashboard for them, which they can log into. They can monitor their equipment. They can drill down. Of course, you have your basic OE type information. They can drill down even further and analyze any data point that we've captured, be able to graph it, trend it, analyze it down to an individual, maybe alarm. You may pick an alarm and say, how many times this alarm happened over the last 6 months? And you can plot it out and see. And that is it. So thank you.